Hi everyone. In this video we will start talking about new mover component. After 2024 and 2025 Unreal Fests, it became obvious that Epic's team is making a big shift towards a new generation of character gameplay tech. Two big innovations that were announced there are Unreal Animation Framework, also called Anim Next in plugins, that should replace Anim Instance in future, and Mover Component, which should become a replacement for Character Movement Component in future. The important thing here is that Epic Games also said that there are no plans to remove Character Movement Component, so developers could continue to rely on this tech without hesitations. Currently, there is no documentation about Unreal Animation Framework, only an FAQ page because it is in a super experimental stage and they can't guarantee that API will not drastically change in future. But the main idea behind it is that the hardware and game requirements changed a lot after Anim Instance and Anim Blueprints were introduced, and now we need to support a much higher level of multi-threading than previously to create complicated logic on animation and support bigger amount of characters without losing quality. You will find the link to the talk with more details in the description. But there is already good starter documentation for Mover component that explains new ideas implemented there and also does comparison with character movement component. You will find link to documentation and link to video from Unreal Fest in the description. There were several motivations behind this component. Character movement component has very steep learning curve. It does not provide necessary level for customization because of a strong bond into several classes like a character. So it was decided to create component with bigger level of abstraction, modular, and with new ideas inside that will help developers create custom movement systems easily. We will talk more about this in the next video. Mover component has a list of differences with character movement component. Let's focus today on the first three of them, because others are connected to a new replication model that is well described both in talk and in documentation. Also, they are pretty much binded together. We will check how it's done in previous approach and new one. If you take a look at character movement component code, it is a monstrous huge beast consisting of more than 10k lines of code that contains everything inside of it. In contrast to this, new mover logic is separated in several different files, and the component itself is just a manager cloud that manipulates other objects to get velocity and location, but does not do it by itself. As an example, let's take two parts of functionality that can show us how a new approach works and also how mover component removes binding to a character class. They are handling input and calculating velocity. Big disclaimer here. We will take a look for only one flow. We will check only code flows when there is no root motion from animation and we are not taking into account networking. Only movement straight from input. Let's check how input works in character movement component. We can see they're gathering inputs for acceleration, jump and crouch movements. Each tick we create input vector to save values consumed directly from Pawn, and then if we need to perform controlled character movement, we use it to find out current frame acceleration. If we are talking about other inputs like jump and crouch, we can see that character movement component just triggers method from a character class to get current frame values. In terms of jump, in control character move method, component uses a character check jump input method, which checks input and decides if character should jump or not, and if needed activates character movement component to jump method. That in turn updates velocity's Z component and updates movement mode to fallen. And at the end of perform movement method, we clear jump inputs to get correct values next frame. Code that decides whether the character should crouch or not during this frame is located in update character state before movement and update character state after movement methods. First one decides if the character should crouch this frame or stop crouching, and it is done by asking a character class about it. Second method checks if we can continue crouching and if not canceling it. Invoking methods of a character class directly from character movement component makes these two classes be strongly bounded together, and this is what Epic's team wanted to change. That's why mover component goes the other way. It introduces an interface called mover producer interface, and if actor or one of his components implements this interface, it becomes input producer. The main goal of input producer is to populate input command context each frame, and it is done by using a method called produce input. This context is an abstract representation of input that contains collection of different input structs. Having not one input struct but a collection gives us a big level of modularity and reusability. You can separate your input data into several structs and then compound them into different combinations for different actors depending on your needs. For example, Unreal Steam created character default inputs that covers input vector and jump input. You can use it on any of your actors, but if you need more input data like sprint movement on keyboard, you can create a new struct and just add it to the collection. The only rule is that any of these classes should be derived from fmover data struct base. This is a default struct for data used in mover component simulation model. Now, let's talk about differences in velocity calculations. In character movement component, it is done in perform movement method. As we discussed at the beginning, we do not take into account all logic connected to calculating velocity and location from animation root motion or any other source, only direct input. And knowing it, we will go straight to a method called start new physics. Inside of it, we will find a check for current movement mode, and component invokes function that does all computations connected to velocity and location of a character regarding to this mode. All of these functions are implemented inside of character movement component that make its code go big. In mover component, things are different. They do shift from movement mode as enum towards movement mode as the class that encapsulates inside logic for calculating velocity and location of an actor. To properly manipulate different movement modes, mover component introduces movement mode state machine, an instance of which is used there. Its main purpose is to act like a manager class where at first we register all the possible movement modes and then check what mode is active right now, should we switch to another one, should we trigger code on modes transition, etc. And during simulation tick, mover component triggers on simulation tick method of this state machine. Inside, it checks what movement mode is active right now and, if needed, triggers its simulation tick method. And it makes each movement mode to have its own logic for simulating movement in modular manner. After you create your custom movement mode, you can share it between projects or different characters by adding to mover component in Blueprint. For example, Unreal Steam created default movement set, which has implementation of movement modes classes that give mover component the same behavior that was previously in character movement component. You can use it for basic setup. These examples with inputs and velocity shows us how different this stack is. In the next video we will talk more about new mover features. But that's it for today. Thanks for watching the video, and if you want to support the channel, please use link to buy me a coffee in the description. Have a great day and see you in next video.